Okay. One thing that we're going to do that's going to be a little different, this is 1-5 notes. One thing that we're going to do a little different is we're going to start adding a little bit more vocabulary into each one. So what I want you to do is write these down in your notes and look at the instruction. It says, give me your description and an example of each. Now you can use your textbook. Quickly. Just has to be a brief explanation. I mean, like, not very many words at all. Okay? And then if you find an example, write the example down right underneath it. Now I would put them like side by side each other also. Like right open sentence, maybe a couple spaces, a couple lines underneath it, okay? And then I would write set, okay? And just give them like a 2 or 3 word description, okay? Just 2 or 3. Like what's an equation? What can I put down for an equation?
You put like an example?
Yeah. What would be a brief definition of an equation though? What if I tell you about an equation? What does it have? How does it differ from an expression? Has an equal sign. Good. So underneath that I could put what? Has an equal sign. I don't even have to look that up, right? What does solve mean? Solving. Simplify or find the unknown value, right? Find the value for the variable. What can I put for a replacement set? How about the input values? Replacement set could be input values, domain sometimes. What would solution be? Answer, okay. Final answer. Identity. Now, honestly, you guys spend more time doing that, looking in the back. This is what I would do. I'll pull it back up again. It's and it's just. I mean, you don't have to do it, but it's just okay. I'm just saying. This is just a suggestion. Okay, here's your textbook. Maybe, hopefully. Okay, go to turn to the section. What are we doing today? 1.5? Okay, go to 1.5. Now, what do you notice about that? Are some of these highlighted?
Oh,
Is open sentence one of the words?
yes.
Yeah. Okay, mathematical statement that contains algebraic expressions and symbols is called an open sentence. So write that down. Contains algebraic expressions and symbols. That's what I would write down. Let's say contains algebraic expressions and symbols. And there's an easy one right there. It says it contains an equal sign and it's an equal. Okay. And then just here's an example. Put it. For an algebraic expression, or you can put this one too right here. Okay, finding the value for a variable that makes the sentence true. What can I put right there? Makes the sentence what? True, good. The replacement value is a solution. Okay, it's got to be. Here's the idea. Is I feel like that if you guys understand the vocabulary or understand the words or you can understand what we're talking about, okay, it's just like, going to Mexico. It's hard to go to Mexico if you don't understand the language, right? And coexist with the native people there, right? So if you understand the algebra, if you understand the language of algebra, are you going to better understand what's going on? Possibly. Especially when you start reading instructions, trying to figure out what to do. Okay, a set of numbers for which a replacement set for variable may be chosen is called replacement set. Okay, set of numbers may be chosen. A set is a collection of objects or numbers. Each object or number in the set is called the element. The solution set is a set of elements from the replacement set. Is that all of them? Identity? Page, what page? 33. Is there any on the same page? No. At the top, there you go. You can put on that one an equation that is true for every value. Very. Okay? Everybody got it? Very good. And that's what I want you to do on that, okay? That's how I want you to do that. Doing more of it later. Okay? All right, write this problem down. This is where we're gonna use it. Now, does that look familiar? As you guys are writing it down, does that look familiar to anybody?
Yes.
No? Does anybody know what that's called?
Oh,
The shape, the 2 lines and 3 lines?
in and output?
What is this called right here?
In and output table?
Input,
Input, output.
table, what else? A double T table? That's not familiar?
No.
Okay. A lot of times we can use these, especially when we start graphing, when we start graphing lines and we're starting to find, when we start finding ordered pairs to graph those lines, and we'll use a double T table like this, or an input-output table. Okay? And you can use, there's all kinds of applications. Let's say you're going to a store, you can use an input-output table to see what the cost is. If you buy like 1 can of soda, 2 cans, 3 cans, so on and so forth. All right? So basically, all I did right here is what goes for C? What do I put on the left-hand side of the table?
60. What? No. 60. 60.
Very good. 0,
60.
1, 2, 3, and 4. Now I'm basically just going to take these numbers and put them in for what?
C.
C, good. Now on the first one, is that a true statement?
No.
Okay, so what can I put out to the right? This is my solution set. I can put no, or what else?
What? No.
Is 0 a solution to this equation?
Oh, okay.
Is 0 a solution to this equation? No, so I can put no. What else could I put? And now for what? False. Very good, Josh. Okay, let's do the next one. 6 times 1 minus 5. Does that equal 7? No. What about 2? 6 times 2 minus 5. Does that equal 7? Okay. Or I could put true. Good. Now, do I have to do the rest of it?
No.
No. I can go ahead and just put my answers because I know the rest of them are not going to work. Okay, this has one value and only one value. It's going to be a solution, and that's what? 2. Okay, you guys need any more time with that? Yeah. Good, Kai? All right, it fails. All right, see if you can work one. Now, you don't necessarily have to use double T table on this to do. Okay, just got to solve for what? What's all by itself? B, so you got to solve for B, right? This problem is not any different than what you've been working. Okay? Do I need to follow the order of operations on this? Yeah, that's all I'm doing is the order of operations here. Now make sure that you put this on your card. Put your answer on your card too. It should be in your clicker and in your card when you start it. done, Josh?
That's what I got.
You better go back and check your work then. Let's see where you're at. You see it? It's my mistake. See, that's the nice thing about showing your work too. You can kind of go back and see where you made your mistake, you know? Especially if you do like this line. Okay, start up. What's the, you're good. What's the right on there? What's the first, what's the next one? Three down. Okay, plus 4, parentheses. Okay, which is 2/3. No.
Oh,
A minus 2. Keep going. Keep right there. Keep going. Push the tray down. There you go. Back. 6. Where you at? 6. No. Order of operations. 3 plus 4. And now what do you have to do first? Okay, so multiply. Plus. Okay, so 3 plus 4. Okay, good. All right, solve this one. Show your work. You guys just sit there and stare at it, it's not going to work. It's going to take forever to get it answered. Write it down. Perform an operation, write it down. Change the line from one line to the next. I'm telling you guys, it will make a huge difference. Okay? All you're doing is you're transforming the equation. How's it changing? What's up? Yeah, you just got to finish that. There you go. Very good. There you go, you got it. Snapshot? What part? Where at? Three over what?
30%.
Okay, your operations are off somewhere. Okay, so you got 3 times 10, right? Okay, over 21 minus 60.
16.
Okay, so 21 minus 16 would be what? Oh, tell me what you did first, Cal. Yeah, just tell me where. How did this equation change to the next equation? How did it transform? Okay, good. How? Show me. Tell me. Hold on. What'd you do here? Okay, so did you put 3 times 10?
Yeah.
Over?
21 minus 4.
Like that?
Yeah.
That's it. We're just doing the same thing.
Whoa. I know, I'm asking if that's okay.
Yeah, that's okay.
I was just wondering.
I just skipped another step. That's all I did. I just did a couple of steps at the same time. It's still the same thing that you did.
Yeah.
Okay, good.
That's-
Yeah, you'll be all right. Okay, write that one down. As you're writing this one down, what do you notice? How's it different than the other one we just worked? And the other two, the previous two, the variable was
It's all by itself.
by itself. Very good. Okay, what's the problem here?
It's not by itself.
Good. So do you think we're gonna have to get it by itself? Right. So now I need to start being able to move things around, don't I? Okay. First thing I want to do is go ahead and simplify some things if I can. Like, for example, what can I simplify right off the bat?
3 squares.
The square there, to evaluate the power. So I'm gonna go 4 plus what? 9 plus 7 divided by n equals 8. Okay, now what?
Add 9 and 3.
Add 9 and 7?
Yeah.
Okay, plus what? 16 divided by n equals 8. Okay, now, can I move something else?
You can divide 16 by 9. 4 plus
Divided 16 on both sides.
Can divide 16,
4 plus 16.
because I'm not dividing by 16. Can't multiply either.
4 plus 16, 9.
What about, can I subtract 4 from both sides first? Can I do that? Sure, subtract 4. You guys remember what that property is called? What's that property called? Write it down. Here you go. Inverse operation. Because 4 and 8, are they like terms?
Yes.
4 and 8 are like terms, are they not? Okay, so I have to get them together. The problem is they're on opposite sides of the equal sign. Okay, so to be able to jump the equal sign and move it over there, I got to do the inverse property. What do you end up getting now? 16. Now, I would suggest that you do this. Okay? Change this to 16 over what? N. So you can see it a little bit better. Can I leave the N on the bottom of the fraction? How do I get it to the top?
So I'll multiply
Multiply by
4.
N over 1. If I do something to one side, I gotta do it to the other side too. What happens? The N's cancel themselves out. But you end up getting 16 equals 4N. Is the N by itself?
No.
Now I have to do what? Last step. Divide by 4. N equals 4. How many solutions does this problem have? How many solutions does this problem have? One. One unique solution, which is going to be what? 4. No other number I can put in for n is going to make this a true statement, is it? You guys with me? Stay with me to wake up. Okay? Anybody need more time with that? Anybody? Callie? Good?
Yeah.
Okay. Write this one down. Hey, wake up. Write this one down. This is something else that you're going to see. Or another way you're going to see it. What do you notice about this one? How many variables do you have? 2. Are they the same variable? Are they on the same side? Okay, so you know you're going to have to get them together, right? Okay, we got to do an inverse operation at some point. Can I go ahead and simplify first? Okay, here we go. You guys ready? Right as I write. 4n minus what? 14, good. Equals. What's n times 6? It's distributive property, isn't it? Minus what? 2n minus 9. Good. Combine like terms. Okay, what are my like terms here? 4n and 4n. How do I get them together? I gotta do the inverse operation, right?
Where did you get 14?
12 plus 2.
Oh,
Okay. Does something look awkward? Something look off? What looks off, Callie?
I don't know.
What happens to the 4 ends here? They cancel each other out. What happens to the 4 ends here? What am I left with? How can that be possible? The fact is, it can't be possible. What's my answer on this one?
4.
No solution.
Okay.
This is where a lot of people make mistakes, okay? Because they work it out and they get so confused and so frustrated because it doesn't come out right. It doesn't necessarily mean that you're doing something wrong. All it may mean is that you don't have a solution. Okay? Which means there's no number, guys listen to me, there's no number that I can put in for n that's going to make this a true statement. For the left side equals the right side. You guys clear on that? Alright, next slide. Word number 3.
Somebody's fast. Somebody's fast. Who's already answered it? Probably Victor.
You know.
I don't know, he's starting to read Jacob's answer.
And I think I know what it was. When I was doing like already, there already has one on there. Did you do it? Huh? What? Yeah. And that's the one that in the song.
Malik, are you done? Are you done, Malik?
No.
Hey, do that one. We'll go back. I'll say. No, it's not. Susie. Let's go. Quickly. Evaluate your powers on each side. Is that what you're talking about?
No, they can be distributed.
Yeah, evaluate what's inside first and then distribute. You see what I'm saying? Steve's asking a great question. Would I just, on this side, would I distribute first? Or would I solve what's inside of parentheses first? I'd go ahead and do what's inside first. Okay, so that's going to be what? 8 minus 3 times 2. Now here's a common mistake that everybody makes. They subtract the 8 and the 3 first. Don't do that. It should be 8 minus 6, which gives me what? 2n plus 29. So that should be your right side. No. That's on opposite sides of the equal sign. What you have to do. What do we say in our notes? Yeah, you got to do the inverse operation.
Oh.
So you got to move one from one side to the other. Got it. Yeah, what happened? How much do your ends? Right. So what do you have left over? Okay, what do we say about that agreement? The left side doesn't leak to the right side. Just work across those spots. Did we? Those are not like terms, you can't combine them. Now I can multiply this week two again. Plus 29. Okay. Yes. Plus 29.
Yeah. Yes, I'm not sorry. You were a little bit guy. Okay, so what are you looking for? You raise that now.
Is that awesome? Couldn't do it on your real quick. Okay, write this one down. This is the last one. Try to get through it pretty quick.
No, give me like copy.
Are you?
We will later. Well, listen. What are you going to have today? You're going to get a fair check, right? Okay. When you bring that fair check back tomorrow, if you have questions on it, what do you need to do? You need to ask. Okay? I'd be more than happy. Yeah, we'll get that. If not, we'll try to do it tomorrow. Okay? All right, so what do I need to do here first?
Divide 8 and out.
Okay, so 5 plus what?
2.
2, good. Plus 3K. 5 plus 2 is 7 plus 3K. Now, is there anything else I can do on the left-hand side?
No.
No. Go to the right-hand side.
3.
Plus what?
No. Oh, no, 3.
96.
96. Minus 8.
What's 96 minus 89?
7.
What do you notice about this? Look at the left side compared to the right side. They're the same. What does that mean? Any real number will work for K. That's the answer. I can put any number in for K, and it's going to make it a true statement. Okay? You guys understand that?
Oh, the right, the left side are the left side.
It does, but yeah. That worked out.
It's all wrong.
Write the problem down and then I'm gonna give you the answer. Well, we're gonna run out of time. I want you to get it in your clicker before you leave. Okay, so now, we just worked the problem. And I'm asking you to work a problem just after that.
This is gonna be C.
Okay, good. I'm gonna have to change that up, so some of you start to wise up. What's gonna be the answer here? C. Put it in your clicker real quick, please. That way I can give you a right to that. Not paying attention.
Good.
Good.
What's the answer?
Answer is D.
Now, yeah, if you have your prayer checks, where do they go? If you have yesterday's prayer checks, pass up your notes. See those cards.
Thanks, Colleen.
Probably in my way, so.
That's all.
Great, you guys.
This is how everybody did.
Did you?
Prayer checks, I need these for Mr. Day. Okay, any more of these? One
Yes.
more? Bring it to me. Bring it to me. All right, finally.
Go ahead.
What is it, prayer check?
Where you want these?
We all have a church.
Yes. That's right.
We're about to take care of this Oh.